Okay, so the first section in chapter 6, aside from the hierarchies that we already did, are going to talk a little bit about polygons, and then the rest of the chapter is going to zero in on a particular type of polygon called the quadrilateral. But today, we're just going to do general polygons. It's been a while since we talked about this, so I think it's relevant that we review what is a polygon. That was not a rhetorical question, by the way. I'm asking you, what is a polygon?
Any complete shape
Any complete
with straight sides.
How are you defining complete shape? What does complete mean?
Means with angles.
With angles.
Yeah.
Okay,
Like
so
all
then
angles.
doesn't this satisfy your definition?
That's two shapes.
That's two shapes. Isn't it a complete shape though? No.
Well, that's two complete shapes.
Two complete shapes. So those are two polygons.
Yes.
Okay?
Someone could.
How are we feeling?
Someone could say that.
Hello?
A closed shape?
This one's closed, but I like that. That's a good starting point. Good, because this one's not closed, so that takes care of that. Good. It's got to be closed. Martha?
No curved sides?
No curves. Good. Or the sides are made up of segments. Good. That takes care of this. Gets rid of that guy. Good. And how do we eliminate this guy?
No intersecting lines.
No intersecting.
Yeah.
No intersecting.
Sides.
No sides.
Lines.
Well, don't these sides intersect? Doesn't that side and that side intersect?
Oh, the line segments.
Doesn't that line segment and that line segment intersect?
They do.
Uh-huh.
They don't cross each other.
So they don't cross each other.
Yes.
That's not horrible, actually. I'll ask you. Okay. The sides don't cross each other? Beautiful. Okay. Close enough. Oh, by the way, how do you break down the word polygon? What does the prefix poly mean?
Many.
Many. Gon?
Shape.
Sides, actually, but that's okay. We'll go with it. Many sides. So, general term, again, thinking about a hierarchy, the general term of on the top of that hierarchy would be polygon, and then we can branch off into all different types. Here are a whole bunch of different types. Sarah, what's that purple thing called? No. Purple.
I was counting the sides.
No, that's not purple. That's magenta. Purple.
Oh, a triangle.
Triangle. Very good. I gave you the easy one. Natalie, what's that bright green thing called? Okay. Anybody else? Corey, what's that bright green thing called? It is a quadrilateral. Now, some of you may have said, oh, it's a rectangle, it's a square, it's a... No, it's a rectangle, or sorry, it's quadrilateral. Quad, four, lateral, side. You know, in football, you lateral, you throw it to the side. Maddie, what is that baby poop green thing called? A pentagon, very good. Penta, five, gon, sides. You're seeing a pattern here. Parker, what's the white thing called? Beautiful. Hexagon, hexa, six. Gon, sides. From there we go to the boring gray thing. Clarence? Any idea? This one's a struggle.
No.
There's two names for it, actually. Anybody? No, that's the red thing. We'll get back. We'll come back to that in a second. Seven-sided figure? It's okay. I don't fault you if you don't know this. a septagon or a heptagon. We'll use those two names interchangeably. As Maddie said, the red thing you should all know is an octagon. The yellow thing smack dab in the middle, 9 sides. Sam, any idea? A nonagon, very nice. Notice the spelling there. N-O-N-A-G-O-N. And then last but not least, the magenta thing is called what, Vic? Any idea?
It starts with a D.
It does. If you put 52 cards together, you have a
Deck. A gon.
decagon. Good. Okay, now we could spend weeks learning the names of all the other shapes. The only ones you're responsible for are 3 through 12. Oh wait, where are 11 and 12? I didn't include them. Any idea what an 11-sided polygon is called? Okay, so this is where we get into these prefixes and we start to combine things. An 11-sided is called an undecagon. U-N-D-E-C-A-G-O-N. D-I-O-N. Sorry. Undecagon. Therefore, a 12-sided figure would be called dodecagon. From that point on, if you have anything more than 12, we're just going to call it a blah, blah, blah gon. So if you've got 17 sides, it would be a 17 gon. 431 sides would be a 431 gon, et cetera, et cetera. Because we don't want to spend weeks learning that a 17 gon is actually a heptadecagon, or a 431 side is a, I don't even know. And then last but not least, we've got this n thing. What if we don't know the number of sides? Then it would just be an n-gon. The reason I mentioned on the nonagon is to be careful on the spelling is because frequently people get an n-gon confused with a nonagon. Nonagon, 9 sides, n-gon, lots of sides. I would imagine that shy of a septagon or a heptagon, you've heard all these terms before, right? Okay. The other mistake that people make is they want to change the suffix gon into hedra. Dodecahedron, dodecahedra. That's something different. That's 3D stuff. We get to that later. These are gons, 2-dimensional figures. We're good? Hot diggity. Polygon Sum Theorem. Okay, we already know the triangle sum theorem, right? Jessica, what are some of the angles in a triangle? Bingo. Do you know the sum of the angles in a quadrilateral? Julia.
4. Or
What is the sum of the, yes, there are 4 angles. What if I add those 4 angles up? Do you know what you get for a value?
no.
No. How about 5?
Wait, what?
For a quadrilateral? It would be. How'd you do that? Can I guess? You cheated, thought of a square which has 4 right angles, and 4 times 9 is 360. Good. So you couldn't use that for a pentagon, though. No. Okay. So we need a system to figure out what the sum of the interior angles in any polygon is. Triangle easy, because you've had that burned into your skull since you were in 3rd grade. Quadrilaterals you can figure out using the thought process that Julia just went through. You know, a square is quadrilateral, and the square has 4 right angles, and each of those is 90, and 90 times 4 is 360. But what happens when it gets bigger and bigger? So we're going to use a sneaky technique that looks something like this. So the triangle we already know. The quadrilateral we know, but I'm going to show you a different way to do it. If I draw that yellow segment into that quadrilateral, it splits the quadrilateral into triangles. You with me so far? What are the sum of the angles in a triangle? 180. We've got 2 triangles. Therefore, 360. Bingo. So let's make some notes. 180 with 1 triangle. that's kind of silly, but we'll go with it. 360, 2 triangles. We got to your baby poop pentagon over here. Oh, you're going to need your calculators, by the way. If you don't have them out, bust those puppies out. Because I need to know what 3 times 180 is.
Isn't it like?
Come on, Sarah, you got this. 540.
Oh,
Hot diggity. Jump over to the hexagon. 4 triangles. 4 times 180. 720. And then the heptagon. 5 triangles. Whoops, not 5 A's. 5 triangles. What's the total?
900.
900. Okay, we good? Sounds great. There's 3 through 7. But suppose I says to you, what the heck just happened? Suppose I say to you, what's the sum of the angles in a 17 gon? How many triangles would a 17 gon have?
7.
Claire?
15.
How do you know that?
Is it like 2 minus the amount of sides there are?
The other way around, number of sides minus
Yeah.
2. Right. So notice we had quadrilateral, 4 sides, 2 triangles, 4 minus 2, 2. We had 7 sides, 7 minus 2 is 5, 5 triangles. So Claire, you're arguing then that a 17 gon would have 15 triangles, which would give me a sum of in other words, I don't know what 15 times 180 is. How much? 15 times 180, yes.
Yeah, 2700.
2,700 degrees. Love it. Okay, good. What was the other one I used? 431? So if I have a 431 gon, how many triangles? 429. Okay, great. This is fun. We can play this game all day, but what if we have n sides? In other words, let's come up with a general equation so we don't have to play this triangle game all the time. And we can just plug and chug, because I know a lot of you like to plug and chug. If I have a polygon with n sides, how many triangles do I have?
0.
Audrey? N minus 2. And like we did in all these other patterns, we take the number of triangles and multiply it by 180. Okay. Capital S, sum of interior angles. So again, staying with our pattern, instead of just giving you a formula and having you plug and chug till you throw up, in Latin that would be ad nauseum. I've given you a little background to help you understand where that formula comes from. Good? Questions on this? Now, how do we check it? Well, put in 4. What if we got a quadrilateral? 4 minus 2 is 2 times 180, 360. Checks out so far. 7 minus 2 is 5 times 180. 900. Okay, so we get that guy right there, which is exactly what we found. I just rewrote it a little bit differently. Questions? Okay, so next slide we have a couple new terms here. We have something called a corollary. A corollary is an idea that comes out of another idea. So this corollary is based directly on the Polygon Sum Theorem. And the corollary says, what if I have a regular polygon? All right, hold on. Before we go any further, I seem to have forgotten. What's a regular polygon? Anybody? Hasn't been that long. Ryan, any ideas what a regular polygon is?
A polygon that fits all the things we wrote about earlier, like what decides whether it's a polygon or not.
No. Anybody else? A square, for instance, is a regular polygon. What makes a square a regular polygon? And by the way, a rectangle is not a regular polygon.
All the sides are the same length.
And?
The angles are the same measure.
Good. Okay, so a little flashback here to some terminology. We had the term equilateral. Equa meaning equal, duh. Lateral, side, equal sides, and then we had the term equiangular. Equa, again, meaning equal, angular meaning hello, is this on? Testing 1, 2. Is this working here? Hello. What does angular mean? Angles, thank you. These two things combined make a regular polygon. So we'll look at shapes that are equilateral. All three sides are equal. We'll look at shapes that are equiangular. A rectangle, for instance, is equiangular, but it ain't equilateral, therefore not regular. Okay. So this is a polygon with equal sides and equal angles, which explains then why this formula would work. If I go back to this picture, and I look at this little heptagon down here, you can see that the heptagon doesn't have equal angle measures. Some of them are bigger than others, some of them are smaller than others. That is a non-regular heptagon. So the only thing we can solve for in that puppy is the sum of all those angles. However, if we have a shape where they're all the same angle, if we take the sum and divide by the number of angles, we get the measure of one of the angles. Which is how, for instance, in a square, you get that they're 90 degrees. We know the sum of a quadrilateral is 360, but all of a sudden all four angles are the same. Divide by the number of angles, we get them being 90. Does that make sense? Okay, so if we go back even further, that's a regular octagon. We should be able to find the measure of one of those angles, like that guy right there, using this corollary. Do it. Whoops. Once I give you a little bit of time to cook that, then we'll talk about two different ways to solve this problem. We want to give you as many weapons in your arsenal as possible. All right, first of all, simple question. Krish, what's n for an octagon? 8, good. Method number 1, plug and chug. 8 minus 2 times 180 divided by 8. By the way, those 8s do not cancel. Don't do that or I will make fun of you. Answer? Julia? 135. Can I get a confirmation? Awesome. Those are degrees. Okay, that's method number 1. Method number 2 is a little more philosophical. I know that the sum of all the angles in an octagon can be found by doing 8 minus 2 times 180. So I would then do, man, thank you, you're a good man. 6 times 180 is 1080. If the sum of all the angles in the octagon is 1080, so S would be 1080 for an octagon, and I know that a regular octagon has all the angles equal, then I can take 1080 and divide it by those 8 angles. 135. Now, realistically speaking, many of you are just going to go home, memorize that formula, and try to kick it back to me on the next quiz. Problem comes about is when you forget that formula. So an understanding of what you're doing versus just plugging and chugging, in my opinion, is important. Questions? Also notice, only regular polygons. I cannot go back to this original picture and say, oh, I'm going to use that to find the angles in that baby poop pentagon. Doesn't work because that's not a regular pentagon. Okie doke. We did that already. Let's skip that one. Yeah. Mm-hmm. Ooh. Quadrilateral. What do I know about angle R, angle S, angle T, and angle U? Ashley?
Angle S, angle U are the same, angle R, angle T are the same.
Good. What else do I know?
Angle U and angle T at equal 180, maybe? That
All 4 angles?
equals 360.
Bingo. All 4 angles equal 360 because it's a quadrilateral. Now you might be saying to yourself, that's a parallelogram. I don't even know what that word is. We're not ready for that yet. Let's just take baby steps here. It's a quadrilateral. Add up all 4 sides. I cheated. 2 times 11x plus 4 and 2 times 5x. Okay, because I'm a math guy. Has to equal 360. I solve for x, plug it back in. Common mistake in these types of problems, people stop when you get x. Well, I solved it. X equals 11. That's not what the problem is asking you. It's asking you for the measurements of the angle, so you have to plug and chug. And actually, what you said is also true. Notice that angle U and angle T add up to 180. But we'll get to that later. It's irrelevant in this situation. Drink of coffee. It's a good batch today. Going back to the octagon. And the reason I want to go back to the octagon is because now all of a sudden we have a word problem. People hate word problems. 6 angles in a convex octagon are congruent. Okay, so here's my octagon. I'm going to pick 6 of the angles. 1, 2, 3, 4, 5, 6. Those are all equal to each other. But I don't know how big they are. Therefore, how would you like to label them? If you don't know the measure of something, what do you commonly use to refer to its measurement? X. Beautiful. X, 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 and X. Each of the other 2 angles has a measure 20 more than the measure of the other 6 angles. Therefore, how do I express the measure of this angle and that angle? Hot diggity. And what do I know about all 8 of those angles? What do they add up to be? 1080. Good. X plus 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 20 plus X plus 20 equals 1080. That's 8X plus 40 equals 1080. I'm not going to sit here or stand here and wait for you to solve that because I'm assuming you can all solve a simple linear equation. Yes? Beautiful. Great. Let's move on. Your answers, by the way, would be 130 and 150 in case you care. Remember, more than is addition, times is multiplication, Less than is subtraction when you get into those word problems. Okay, Doc, almost done. Solve for x. This one you're on your own. When you get an answer, check with the rest of your group. By the way, Corey, just to help people out, what shape are we dealing with there? What is that thing called? Hexagon. Very good, thank you. You got smart advance. Oh. I think so, huh? Where did the 6 come from? Get it over here.
Would you go? I got one.
Oh,
I missed the yeah, one second.
All right, let's move on because I want to give you a couple minutes to finish up with your hierarchy. So, I saw a couple of different approaches to this. Some people recognize that that's a hexagon and did 6 minus 2 is 4 times 180 tells me that the total angle measure is 720. Yes? However, some people also did this. Which is cool. 1, 2, 3, 4 triangles, 4 times 180, 720. Regardless of how you get it, we know that the sum of those angles is 720. And then I know 5 of the 6 angles. 110, 120, 160, 130, and 90. I forget, what is that added up? 610? Right, so we take all those angles, add them up, we get 610 plus x equals 720, so x equals $1.10. Problems? Nope. Hot diggity. Okay. Again, moving on. What about the exterior angles of a polygon? Oh, I guess we should refresh. What's an exterior angle? So here's my polygon. We know that this is an interior angle. An exterior angle, if I extend this side, is that guy. It is an angle that forms a linear pair with an interior angle of a polygon. Okay, so 2 approaches. First approach, just memorize that it's 360. Second approach is think about if you walk around this shape. Start here, you turn. You go all the way around this shape. As you continue to turn at each of these angles, when you get back to the start, you're facing the same direction you started. 1 full revolution is 360. Okay, So I'm going to change the example. I don't want to know the measure of this exterior angle. I actually want to find the measure of this angle. I'm going to show you two different ways to do it. That's a regular decagon. How many sides? 10. Right, so I could do 10 minus 2 times 180 divided by 10. Somebody do that quick and tell me what the answer is.
144.
Say again?
144.
$1.44. Thank y'all. However, I'm going to show you a different way to do it. Now, why would I use a different method? Well, just be patient. Let me show you what I got here. As I said, this angle alpha, we'll call it alpha, or fishy, is a linear pair to this interior angle, which we already know is 144. But suppose I didn't know 144. Suppose I was looking for that. I can easily find alpha. How do I find alpha? Alpha is simply 360 divided by 10, because I've got 10 exterior angles here that are all the same measure. That, you can see the pattern here, all add up to 360. So 360 divided by 10 tells me that alpha is equal to 36. If alpha is 36, then the interior angle must be 144. Because again, they're supplementary, adding up to 180. And you can make, question?
Wouldn't you also be able to do 180 minus 144?
Yeah. Yep. If you, so yes, if I was asking you to find alpha, you could totally do it that way. But I'm going backwards. I was actually looking for the interior angle. I changed the problem. Okay? We're not even going to bother with this one because it's just a pentagon. I know that all the exterior angles add up to 360. 2x plus 2x plus x plus 3x plus 4x equals 360, so we're good to go. Okay? Beautiful. We're done. Okay? So, in the last 12 minutes, I would focus on finishing your hierarchies to get those turned in while you're still together as a group. While you're doing that, I'll unlock day 1. And if you have your hierarchies done and submitted, you can start on the day 1 homework.
Did you submit it? Wait, are we gonna solve other people's?
You bet.